Hello there. Today we'll be doing coin change number 2. It is a interesting problem. Let's check it out. In this particular problem, we're looking for a number of ways we can get the amount of coins. And so we're keeping track of two different types of things right here. We're keeping track of the amount and the number of the type of coins we're going to use to get that amount. And we're going to try to get the number of ways we can get that particular amount with that particular amount of coins. Yeah. So first we have 1, 2, 5. Those are a number of coins, and this is the amount 5. So what we're going to do is the most brute force method is to use a branching out. So let's say we select the 1. The only thing that we can select from here is 1, 2, and 5, and we select this every single time. But what the worry here is that what happens if we select 1 from the 2? Well, we're going to have another 1, and that's going to create a problem. So what we're going to do here is keep track of the coin that we used for each layer and remove the possibility of using the 1 coin once we get to this particular layer, so that we can only focus on the 2 and the 5, so that way we don't end up in the mess with a problem. So that way we can only select 2, 2. So like right here, so we have 1 coin, 2 coin, and this 2 coin cannot no longer select the 1, that limiting all the other ones, and we select the 2 coin, giving us a 5 here. And 1, 1, 2, that's another 5 coin, and 1, 1, 1, another 5 coin, and this is our 4th choice, giving us 4 options. And that's how we end up with 4 different types of items, and eliminating a number of different things, multiple coins of the same type. So what we're going to do is create a DFS call, of course, and we're going to collect the item, the index of the coin, and the amount. And with that, if the amount is equal to our target, which is amount, then we're going to return 1. If our amount is greater than our amount, our target, return 0. If I is equal to the length of coins, that means we've exhausted all coins, return 0. And if the particular item is in our cache, then return this particular item, this index, and amount for this cache item, like number of ways we can get there. So otherwise, let's build that particular piece of cache. So is equal to the DFS of the I and the amount plus coins of I. And then we add, basically this is this particular tree, and we're going to add the branching off trees, which no longer uses that particular index. And we're going to go all the way down until we run out of coins, or we're going to hit the amount before we can get our cache for our amount and index, which is 0. So first thing we need to do is set up the DP, so that the cache DP, so that we can access it. So this is a coin index, and the amount, and the value is equal to num ways. So let's return that. Very good. and we have gotten an answer. So let's check out what that cache looks like every time we run the the cache is empty. Very odd. Oh, right, because result in the next video, we're gonna build up the solution rather than so a number of ways from with the second index and the four amount basically means that we selected the 1 and there is still 4 left. Yeah, so there's not much we can see here. Maybe, I mean, the video is only 6 minutes long right now. Let's get the second bit, and then maybe this will help improve our understanding of what's exactly occurring here. Right, so what we learned in this particular method is that once we get the amount, we're going to return 1, and we're going to add that up to our starting point. Once we've exceeded the amount, return 0, and exceeded number of coins, return 0, so that we don't make needless calls, as well as finding if the item has been already searched, like in this case here, so that we can get the number of ways to get that particular amount, because that's all we need based on the particular type of coin that we have at that point. And we're going to return, but the way we're going to skip coins is via this method where we don't take the coin and we remove the possibility of taking that coin. Right, so with that, I think we learned a lot of cool ways to structure our dynamic programming problem and answer these types of questions. So in the next video, and after this explanation, it's already 8 minutes. So in the next video, we're going to go over the bottom-up method and how that allows us to speed this code up, because we're making it O of n by m calculations, and how we can see what this DFS is actually doing in the background better. Okay, thank you very much. Enjoyed the video. Like and subscribe. If you want more videos, check the link in the description below, and I will see you in the next one.